Our seventh exercise, how many elements are in the Cartesian product of sets A that has the elements 1 and 2 and 3 and B that has the elements 4 and 5. Let's do a quick reminder again about the Cartesian product. We know that the Cartesian product of two sets is actually a set that consists of tuples, and each tuple has an element from the first set, and the second element of the tuple has an element of the second set. This is the definition of the Cartesian product. If I go to write down the Cartesian product of these two tiny sets, I have that the elements of the Cartesian product will be one element from set A and one element from set B. 1 and 4 will be the first element of the Cartesian product, and then I have 1 and 5, and I have exhausted the first element of set A, so I go to the next one, the 2, and here I go 2 and 4 and 2 and 5, and then we have another two elements, 3 and 4 and 3 and 5. These are the 6 elements of the Cartesian product, but I want to do something more combinatoric to solve it. So I observe that in a solution there are two positions. The first position comes from set A, so I have 3 options for it, and the second position comes from set B, so I have 2 options for it. So the rule of product applies, because for each pick of the first position there are exactly 2 ways to fill the second position. So again, solution is just in one line. By the rule of product, I have that the solutions are, and I do just a multiplication, 3 elements times 2. There are 6 elements in the Cartesian product of these two sets. We go further now to generalize our previous result, but I want you to observe something important, that your exercise could be just that, okay? It could be just an exercise with n, m's, etc. In this case, it's always useful to solve the exercise by putting particular numbers in your n's, m's, etc., solving it, and then generalizing your result. It's a lot easier this way. So he says to me that I denote this way the cardinality of set A, how many elements there are in a set. The cardinality of this set up here is 3, and the cardinality of this set here is 2. So how many elements are in the Cartesian product of A1, A2, up to A index 10? In other words, what's the cardinality of the set of the Cartesian product of all these sets? As we've seen, now it's very easy to generalize our result from the previous exercise. I'm going to apply the rule of product. And I have that the elements in this Cartesian product will be the cardinality of A1 followed by the cardinality of A2, and I apply the rule of product between them, and this is my final solution, times the cardinality of the set A index 10.